In these problems, we're being asked to find the absolute minimum and maximum values of a function on some closed interval. So we've got a function, we don't know what it's doing, maybe it's going all over the place, but we're only looking at it in some specific set of values, maybe from there to there. And we're being asked to find the maximum and the minimum values of that function. So the general approach to this is to take the derivative and look at where that might be zero, because that could be a local min, as in this picture, or it could be a local max. So you'd want to test that value. But you also want to test the endpoints of your interval, because maybe this is the maximum of the function, or maybe this is the maximum of the function. So that's the general approach. Take the derivative and then test endpoints and zeros of your first derivative. Our interval here is from 1 to 3. So we'll keep that in mind, but let's start by taking the derivative. And this particular topic in ALEKS is a little bit tricky. There's a lot of work to do, and they're giving you functions that involve exponentials or logarithms. In this case, we have to apply the quotient rule. Others require the product rule, and in addition, the chain rule. So these can get a little bit involved. This one is actually one of the easier ones. Let's see if we can get through this step by step. First, we're going to try to take the first derivative by applying the quotient rule. And I always remember that as low d high minus high d low over low squared, low being the denominator. So low, 5x squared plus x plus 1 times the derivative of the numerator. So low d high. Luckily for us, the derivative of e to the x is e to the x. And then minus high d low. So e to the x times the derivative of what's on the bottom. That's 10x plus 1. And all of that goes over low squared. So 5x squared plus x plus 1 quantity squared. So there's our first derivative. Let's see, I'm going to simplify the top of this a little bit. So we're going to multiply the e to the x through. So 5x squared e to the x plus x e to the x plus e to the x minus 10x e to the x plus, oops, no, minus e to the x. So right away, you're going to have those cancel out. And this, of course, is still over 5x squared plus x plus 1 quantity squared. And let's see, we've also got a plus 1 x e to the x minus 10 x e to the x. So this is going to be 5x squared e to the x minus 9 x e to the x. And the rest of it's canceled out, and that's over 5x squared plus x plus 1 quantity squared. Okay, so I think we've gotten to a point where it's just pretty simple. Actually, I'm going to factor out an e to the x on top. So e to the x gives us 5x squared minus 9x. So where are the zeros of this derivative? Well, I think in this case, I'm going to look for where the top is 0, because if the numerator is 0, then the whole fraction will be 0. So if we set just this top equal to 0, the first thing I can do is divide by e to the x and get rid of that. And so I've got 5x squared minus 9x equals 0. I'll factor out an x, and I've got 5x minus 9. If we set each of those equal to 0, we'll get 2 zeros of the function. So we'll have x equals 0 and x equals 9/5. Now, let's remind ourselves about our interval, because we don't necessarily want to test points that we don't have to. 0 is not in the interval. 9/5 is. So the points we have to test are not that one, but 9/5, and we have to test the endpoints of the interval 1 and 3. And we're going to be doing that by putting it back in this function up here. So if we put in, well, let's do it over here. If we put in 1, that's going to be easy enough. That's e over 5 plus 1 plus 1. So that's going to be e over 7. Okay, so at 1, the function equals y equals that. Okay, let's try at 3. So at 3, we're going to have e to the third on the top, and then we're going to have 45, 48, 49 on the bottom. Okay, and at 9/5, this will be a little more annoying. Let's see, we'll have, well, e to the 9/5 on top, and let's see, that's going to be 5 times 9/5 squared is 81/25. This is plus 9/5 plus 1. So that's 81, dividing that in there, 81/5 plus 9/5 plus 1. So that's 90/5. Yeah, plus 9/5. Nope, sorry, I added the 9/5. 9/5 plus a 1, so 95/5. That is 19. So we've got e to the 9/5 over 19. Now you've got all these expressions with e to different powers. How do you tell which is the max and the min? I would just plug them into a calculator and see what they come out as. I did that, and this is about 0.38, the e over 7. E to the third over 49 was around zero point 0.4. And this one, e to the 9/5 over 19, came out to be 0.32-ish. And that's enough detail to see that this is our minimum. So that's the min. And this is our max. Okay. So that is how to find the absolute minimum and maximum values of a function on a closed interval. I wish you the best of luck with this, and ask your teacher for help when you need it, because some of these problems are quite a bit tougher than this one. All right. Thank you.